our last paper is by Maria Laura Leonardi, Daniel Oliveira, and Miguel Azenha of the University of Minho. And it is titled HeritageBIM, Current Developments and Challenges.
So, hello, good afternoon, everyone. My name is Miguel Azenha, and I'm here to be the first half of the speech that will be delivered by myself and Maria Laura Leonardi, who is working also as I am at the University of Minho in Portugal. And we had the pleasure of hosting Marco Cavalazzi for a certain period back home, where he could manage to witness some of the strange things that people in the construction industry are doing with this thing that we call BIM. Okay, and basically I will deliver the first half of the presentation where more general content will be delivered in regard to what is BIM, and then the second half of the presentation will be held by Maria Laura, who will be more delving into what is BIM doing for heritage construction and for some relationship it might have with what's going on with archaeology, namely. And yeah, with that being said, I will jump to, there's a little bit of content, so I'll deliver first part, and then second part and conclusions will be Maria Laura. So let's delve a little bit into this. So speaking about building information modeling, what we can say is that the construction industry is a very complicated one. So normally it's a typical different industry from other industries where the factory is at the location and the product needs to go to the location rather than the product being manufactured at a certain factory at a fixed location. The factory is always changing location in construction. And it's not only that, the suppliers are always changing. So you have different people for different projects delivering different designs, different materials, and it's always a new team that is built every time you build a new construction. So the collaboration and the exchange of information is very hard. And we have what you see on the left-hand side of this slide. The work is normally very disorganized. We have to wait for each other to finish their work, to start our work. And communication is very hard because even before the time of email, there were problems in communicating. After emails, CCs and cross communications were always a problem. And information sharing was really hard. So this was something that was happening up to a few years ago because we didn't have collaborative practices such as BIM, which is what I'm going to show. Also, on the right-hand side of the picture, we see that our type of constructions throughout the years started to become more and more unique. So that picture of all the buildings being very similar to each other in many urban areas and even outside urban areas started to disappear, and more and more buildings and constructions in general start to have more and more identity as compared to the beginning of the middle of the 20th century in normal construction, not in unique construction, because we know there's an amazing heritage going on. Yeah, but then we need to look at what happens in the construction industry to allow us to deal with complicated things, yet still maintaining our business of architecture, construction, and engineering. And one thing that I really like to see is this saying that we have on the top right: if an image is worth more than 1,000 words, then a model will be worth more than 1,000 images. And this is one of the things we do with BIM. We represent buildings with 3D models, but these 3D models will have an extreme accuracy, not only from the graphical point of view, but also from the information that is put into the model. And then I show you a definition, which is very important. So I will stop a little bit on this bottom paragraph of the picture. What is BIM? BIM is a methodology. So that's the first point. And it's used for information sharing and for communication. So there are two purposes: information sharing and communication. Between whom? Between everyone in the construction. So all the stakeholders, architects, engineers. You may be working in design, you may be working in the construction, you may be working in facility management. Whatever you're working at, if you're involved in the construction industry, you're an interested party to BIM. And then when? In all the stages of construction. So we worry about the preparation of the construction, but also the operation and the demolition. And so we embrace all the life cycle. And yes, this will be supported by a digital model. and this will have software. So the models and BIM are connected, but BIM is not modeling, okay? And we will do very smart things with BIM, like manipulating a vertical construction and do very, very interesting uses. We normally call them uses or purposes with BIM. And here we see some of them. So we visualize very smartly our models. We take quantities, so we can estimate the quantities that we need to build based on a 3D model with information, which allows us to know much more about the construction than in previous approaches where we were using 2D drawings. We can integrate with analysis software. So, for example, I can pick up a building for which I model the structure, and I can send it to structural calculation very quickly. And Maria Laura will show you an example of such quickness of making structural calculations. And we can be speaking also about energy calculations and acoustic calculations. So whatever we need to understand the behavior of our buildings. Another thing that is really important, it's compatibilization and clash detection. So before the construction is made, we are actually able to join the different domains of engineering. So architecture and engineering, I mean, so the architectural project, the structural engineering, the piping engineering, and all of them together in a single model, not a single model, sorry, all of them seen together. They are different models because they have different authors, but all of them together will materialize what we call the compatibilization analysis. So we are actually figuring out what touches what, and before construction, where a clash would be a very big problem, we can anticipate this and solve it in the digital world. And then we can do planning of construction, which is called 4D, planning of construction and costs. So 4D is time, 5D is costs. So we plan construction in terms of time and costs. We plan the operation, which is this facility management, BIM-FM, and we can do sustainability analysis. So basically, whatever we need to extract from the information of a BIM model, we can do all these things in a very seamless way because the information is there to our purpose. And of course, it goes throughout the entire life cycle, including the demolition. Yes, we do demolition with BIM. We do digital models to tear buildings apart. And one of the fundamental cornerstones in BIM is that you must have interoperability. So there are many software houses doing different formats of files. And in BIM, there's this international agency called Building Smart that is helping us with this logo we see here in the bottom. Between different software houses, you can actually exchange information without any losses or without major losses. Let's not say without any losses, but there are sometimes losses because of incapacity of some software or incapacity of some person using the software. But mostly speaking, the market is now using neutral files, which is very good for public tendering and public construction, that you're not depending on a certain file format. And for information sharing with the world, it's very convenient. And Building Smart, this agency that I mentioned, it's a non-profit association that is actually curating file formats for the entire world to use in construction. And it's not only about the IFC file, which is the main character there. This is the main file they use. So all BIM models are saved in IFC formats when you want to interoperate, but then you will have plenty of other ecosystems that will allow you to interact with different stakeholders in the world. So this is a very important part. And just to highlight a couple of situations we are having back home in BIM, two projects that we are participating in. This one we are members, which is called the Czech project. And then I will speak about Recycle BIM, where we are the leaders. So on the Czech project, we are one of the 3 projects in Europe funded with 5 million euro to imagine in each one of these projects how the urban permitting processes will take place. And we are just digitizing all the regulations. I mean, all the regulations, no, many regulations. And we are digitizing them and helping the 3D models to connect with the geographical information systems and figure out, is this building according to the law or not? So to accelerate processes and facilitate life to everyone, the regulations are being now analyzed and improved digitally. So, and we are creating some ways to automate these verifications with some low-code solutions like code blocks, as I show here, that will create Python scripts that you can actually digitize a regulation without knowing programming. This is important to to the municipalities to implement. And then we are creating a web-based solution where actually you can interact with your BIM models and check. You see on the left-hand side, sorry, it's written in Portuguese, but it's a report where certain articles and clauses of the regulation are being verified for validity or not. And this is going on, and in 1 year, we will have the project finished and many outputs coming out. And finally, I will just speak about the Recycle BIM project. And because I'm a little bit late in time, I will advance immediately to this screen, which is much more suggestive. We are looking at buildings that are about to be demolished, and we collect with laser scanning solutions very quick information about the buildings. We make inspections of the buildings, and before demolishing them, we make BIM models that we export to a database, and this database will make the materials and the products like windows, doors available to a marketplace. This marketplace will allow the market to decide whether the demolition will be a harsh demolition by just tearing everything down, or a selective demolition by selecting carefully removing the windows, carefully removing the doors, because someone else will use this in another construction. And this is something that will have a lot of impact in the demolition and circularity industries in Europe. So with that being said, I hand the speech back to Maria Laura, and have a great talk, Maria. Thank you.
Hello. Can you hear me properly?
Yes.
Yep.
And are you seeing the screen with the presentation correctly?
Yes.
Yes, hope so. So good afternoon, everyone. Thank you a lot, Marco, for inviting for this presentation. So I'm gonna speak a little bit about HeritageBIM, or called also HBIM. Nowadays, with the term HBIM, we universally recognize the application of BIM methodology to the built heritage. In the early ages of HBIM, it was published this very famous paper where they propose a library of parametric objects for historical construction, namely a set of algorithms to model architectural orders. Let's say that the components of architectural orders are straightforward representatively by means of parameters to indicate the proportion between parts. And in such case, the use of BIM appears to be like the natural transition from two-dimensional representation to three-dimensional models. The case is a little bit more complex when, beside representing the ideal shape of a well-defined typology of architecture, the goal is to represent the uniqueness of a specific building. This is because most of the time heritage buildings are characterized by the presence of damage or irregularities, which are not often so easy to represent in BIM, which is why the scientific community focused a lot on the implementation of reverse engineering process to deduce in an automatic or semi-automatic way a more precise geometry using advanced acquisition tools such as a scanner or photogrammetry, and in such a way, in a similar way of what sometimes is done for archaeology. Another problem, another difficulty on the use of HBIM is the necessity of adapting a structure of data that was originally conceived for the design of new structures to heritage building. And this concerns both, let's say, the architectural, the structural components, which might be very complex, but it just imagine, for instance, the presence of very complex roof structures, vaults, but it also concerns the existence of new objects in the heritage building, such as, for instance, the patina or this film that depositates on top of stones that needs to be modeled and that are not present when we are dealing with design of new construction. At the same time, there is also another problem that is another, let's say, challenge, that is the so-called semantic interoperability, because when we are dealing with heritage construction, many times we need to connect the information that we have in our BIM model together with other data that have different formats. So what we want is to guarantee that the meaning of the data that we have in our BIM model is maintained through the data exchange with these formats. So, with this in mind, the scientific community and the researcher in the field that are related to HBIM have been exploring for long the use of ontologies and linked data. So an ontology is a formal specification of terms and relationship of a domain. And when we use web ontology language in particular, we are proposing a representation which is human readable, but at the same time machine readable, which ensure a big interoperability with new technological systems such as Internet of Things and new technology. In the linked data approach, it's possible to connect these different domains coming from different ontologies. And what we have nowadays is also that the structure that Miguel was speaking about before, the industry foundation classes, has been already translated in semantic web language. So what we can do basically is semantic enriching a BIM model, adding this new information that were not in the structure of the IFC, and at the same time ensure this big net of data with a great interoperability. And the idea is that every time someone define a new ontology, this ontology should be accessible and well documented in order to have something reusable and to expand always our domain of knowledge concerning a certain topic. And the linked data, building data community group is now taking care of these aspects, is a part of the World Wide Web Consortium. What we did in this direction was to propose an ontology in order to define for heritage structure made in reinforced masonry, in historical reinforced masonry, to define the mechanical properties, because our scope is to perform the safety assessment mainly under seismic activity of historical construction that demonstrated to be particularly vulnerable to this. And one of the main problems is the definition of the most suitable mechanical properties, because the mechanical properties of masonry depends a lot on the morphology of the stones, on the material. So in our ontology, we want to represent clearly that and to interfere the mechanical property in the most trying to be the most accurate. And in particular, we implemented two methodologies to do so. First of all, we included in our ontology a set of, let's say, typical masonry that are already well documented in literature. So the user of our system can directly select a type of masonry which corresponds to the masonry of the wall that you want to assess. And in our ontology, we already have the mechanical properties that are the most adequate. Or in case it has a more complex masonry or less common, what we can do is to provide a very detailed description using the classes that we propose in the ontology, and then with a set of rules that are already existing in literature and that we embedded in our ontology, we can interfere the mechanical properties. Here I'm showing, let's say, something that we presented at the Comware conference. So we have a BIM model and we have our ontological model. And in that case, the scope was to show most plausible failure mechanism. And here we can see, in this case, how we were parsing using JavaScript the ontology, and based on what we want to obtain, it was enlightening some element in the BIM model that had a correspondent element in the ontology. In here, I wanted to provide just a wider idea of what can be done in this linked data system. This is an ontology that we are publishing now in the journal Archeologia e Calcolatori, where we propose this historic survey ontology, and the idea is to clarify in the historic survey of Masonic construction which were the sources that we use during the survey. So, for instance, books that are directly or indirectly related to our artifacts, photos, and we want to make clear which type of data we, let's say, acquire from which source, because based on this interpretation of data, then we decide our modeling assumptions. So it's very important for us to be clear. And also in this system, we managed to map and to put together, let's say, even different types of representation that we have of our building. So different BIM models with different level, let's say, of detailing, point clouds, drawings, and we put together, let's say, various information in this net of data. So our final goal, as I said before, it was to perform structural analysis. Professor Azenha was already saying that it's possible to use a BIM model to perform structural analysis, to perform different simulations. What happens using commercial software often is that commercial software for structural analysis are not very ready for historical construction. So what we did was to create our interoperability tool, starting from IFC files, so starting from the open format, so everyone can use this tool, is not strictly related to the commercial BIM software, and create this algorithm in order to translate our BIM model into a mesh of finite element, to perform structural analysis in a software, let's say, that is way more adequate for heritage construction, which is open system. Everything in our code is free and open. This has been published in GitHub, and everyone can access, because we just decided to use open tools. And here I wanted just to give an overview of our results that has been, in any case, published in the journal Computer and Structure. So we apply our code in a structure that is quite complex, of a real study case in the city center of Ortigia, Syracuse, that is in the south of Italy. And we managed to perform structural analysis in a reasonable amount of time, and starting in a really from the BIM model. What I want to underline again is that our method is completely scalable for every type of geometry. So we can use this algorithm, and we did a very long work in order to ensure that even with very complex geometry, this algorithm would work. To conclude, what we wanted to transmit today is how building information modeling is changing the architecture, engineering, and construction industry, and how this is also reflecting in the field of heritage conservation. Also, we wanted to present a little bit of our work in terms of ontology and use of linked data. So how can we adapt BIM to a content that is more coherent to what we want to represent in built heritage, and our interoperability framework to use BIM model in order to perform finite element analysis. So thank you all for the attention.
Very much. So this concludes papers for the afternoon.